Hello everyone, welcome to our online class Grade 8 Max Chapter 1 Rational Numbers Part 4. Today we are going to discuss about representation of rational numbers on the number line. You have learned to represent natural numbers, whole numbers, integers and rational numbers on a number line. Let us revise them. Natural numbers. You know very well, natural number is start with 1 and going for without end. Whole numbers start with 0 and going for without end. Integers. The set of all whole numbers and corresponding negative numbers are called integers. Rational numbers. A number which can be written in the form of p by q, that is called rational number. How do we represent rational number on a number line? A number line something like this. Positive integer represent towards right of 0, negative integer represent towards left of 0. It is easy to plot integers, but how do we plot rational numbers? Before we understand how to plot this, we need to understand crucial points. Now we divide the length between 0 and 1 into equal parts. How many equal parts in this question? The denominator tells us the number of equal parts. The denominator is 2. So we divide into 2 equal parts. Suppose the denominator is 3. So we divide into 3 equal parts. The denominator is 7. So we divide into 7 equal parts. See the number line. 0, 1 by 3 and 1. Which number lies between 1 by 3 and 1? Also, the first of equally spaced point that divides the distance between 0 and 1 into 3 equal parts can be labeled 1 by 3 as on number line. How would you label the second of this division points on the number line? So second one is 2 by 3. Next one is 3 by 3. Next one is 4 by 3. The point to be labeled is twice as far from and to right of 0 as the point labeled 1 by 3. So it is 2 times 1 by 3 is 2 by 3. You can continue the label equally spaced points on the number line in this same way. In this continuation, the next making is 1. You can see that 3 by 3 equal to 1. Cancel the term, you get 1. So 3 by 3 after 4 by 3, 5 by 3, 6 by 3. 6 by 3 can be written in 2 because cancel the term, you get 2. 6 by 3 after 7 by 3, 8 by 3, 9 by 3, 10 by 3 and so on. See the number line. 0 by 3, 1 by 3, 2 by 3, 3 by 3 and so on. So the denominator decides how many equal parts are which number to divide the rational number line. Similarly, represent 1 by 8. The number line may be divided into 8 equal parts as shown as 0 to 1. So we use 1 by 8 to name the first point on the division. The second point of the division will be labeled 2 by 8. Third point is 3 by 8. Fourth point is 4 by 8 and so on the number line. See the number line, you get idea. 0, 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, 8 by 8 can be written 1 by 1, 8 by 8 after 9 by 8. Any rational number can be represented on the number line in this way. In a rational number, the numeral below the bar, that is the numerator, tells the number of equal parts into which the first unit has been divided. The numeral above the bar, that is the numerator, tell how many of these parts are considered. So a rational number. Rational number between two Rational numbers between two rational numbers. Can you tell the natural numbers between 1 and 5? They are 2, 3 and 4. How many natural numbers are there between 7 and 9? Yeah, it's 8 only. How many natural numbers are there between 10 and 11? Obviously none. List the integer that lie between minus 5 and 4. There are minus 4, minus 3, minus 2, minus 0, 1, 2 and 3. How many integer are there between minus 1 and 1? Yeah, it's 0 only. How many integer are there between minus 9 and minus 10? Obviously none. We will find definite number of natural number between two natural numbers. How many rational number are there between 3 by 10 and 7 by 10? You may have thought that they are only 4 by 10, 5 by 10, 6 by 10. It's wrong. But you can also write 3 by 10 as 30 by 100. How? 3 by 10, that both numerator and denominator multiply by 10. 3 into 10 is 30, 10 into 10 100. So likewise 7 by 10 can be written as 70 by 100. Now the numbers 31 by 100, 32 by 100, 33 by 100 and so on. Likewise 3 by 10 can be written in 3000 divided by 10,000. So 3 into 1000, 3000, 10 into 1000, 10,000. Likewise 7 by 10 written is 7000 divided by 10,000. Now we see that the rational number 3001 divided by 10,000, 3002 divided by 10,000 and so on. How many rational numbers are there between minus 1 by 10 and 3 by 10? Obviously 0 by 10, 1 by 10, 2 by 10 are rational numbers between the given numbers. If we write minus 1 by 10 as minus 10,000 divided by 1 lakh and 3 by 10 as 30,000 divided by 1 lakh, we get the rational number minus 9,999 divided by 1 lakh, minus 9,998 divided by 1 lakh and so on. Between minus 1 by 10 and 3 by 10, you can write a lot of rational number. You will find that you get countless rational numbers between any two given rational number. You get countless rational numbers between any two given rational numbers. Okay, let's see the example 6. Write any three rational numbers between minus 2 and 0. Solution. Minus 2 can be written as minus 20 by 10. How? Minus 2 can be written minus 2 by 1. So the minus 2 by 1 multiply on both sides by 10, you get minus 20 by 10. Minus 2 into 10 minus 20, 1 into 10, 10. And also 0 can be written as 0 by 10. 0 by 10 answer is 0. Thus we have minus 19 by 10, minus 18 by 10, minus 17 by 10 and so on. So you can write between minus 2 and 0. You can take any three of these. Okay, next we solve example 7. Find any 10 rational numbers between minus 5 by 6 and 5 by 8. See the case. Solution. We first convert minus 5 by 6 and 5 by 8 the rational number which of the same denominator. The rule number 1 is the denominator should be equal. So we want to take a LCM. So you want to take a LCM 24. So 24 means 6 into 4 24 minus 5 into 4 minus 20. Likewise 8 3s are 24. So 8 into 3 24 and 5 into 3 15. So the given fraction is minus 20 divided by 24 and 15 by 24. So you want to write 10 rational numbers. Thus we have minus 19 by 24, minus 18 by 24, minus 17 by 24, and so on. As the rational numbers between minus 20 by 24 and 15 by 24, you can take any 10 of these. It's easy one. Example 8. That is the another method to finding the rational numbers between any two rational numbers. Find the rational numbers between 1 by 4 and 1 by 2. Solution. We find the mean of the given rational numbers. That means the given two rational number is 1 by 4 and 1 by 2. We want to add the two rational numbers and divide by 2. So 1 by 4 plus 1 by 2 divided by 2. So take a LCM and add, you get 3 by 4 into 1 by 2, you get 3 by 8. So 3 by 8 lies between 1 by 4 and 1 by 2. This can be seen on the number line also. See the number line. Between 1 by 4 and 1 by 2, you can write 3 by 8. We find a midpoint of AB. So that is the midpoint is C. Represent 3 by 8. So we find 1 by 4 less than 3 by 8 less than 1 by 8. So if A and B are two rational numbers, then A plus B divided by 2, the rational numbers between A and B such that A less than A plus B divided by 2 less than B. This again shows there are countless number of rational numbers between any two given rational numbers. That is the another method. Chapter 1 Rational Numbers Exercise 1.2 Sum number 1. Represent these numbers on the number line 7 by 4 and minus 5 by 6. Sum number 1. 7 by 4 you can write in the mixed fraction of 1 3 by 4. So in the denominator is 4, you want to divide the numbers by 4. So 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4 is 1, 5 by 4, 6 by 4, you want to locate the 7 by 4 easily. Likewise, minus 5 by 6, the denominator is 6, you want to divide the whole number line divided by 6, you get answer. Question number 4. Find 10 rational numbers between minus 2 by 5 and 1 by 2. For this case, the denominator is not equal. One is 5, another is 2. So you want to take LCM. 5 into 2 is 10. So the LCM is 10. So minus 4 by 10 and 5 by 10. Again, you want to multiply by 10 or 5 or 20 or 100. You can write easily 10 rational numbers. Again, minus 4 by 10 multiply by 2. You get minus 8 by 20. 5 by 10 multiply by 2, you get 10 by 20. 10 rational numbers between minus 2 by 5 and 1 by 2 are minus 7 by 20, minus 6 by 20, minus 7 by 20, minus 4 by 20, minus 3 by 20, minus 2 by 20, minus 1 by 20, 0, 1 by 20, 2 by 20. Sum number 7. Find 10 rational numbers between 3 by 5 and 3 by 4. See the denominator that is not equal. So we want to take a LCM. So 5 and 4 is 20. The LCM of 5 and 4 is 20. 5 into 4 is 20. So we need to convert the term, denominator is 20. So 3 by 5 into 4 by 4. 3 4s are 12, 5 4s are 20, and 3 by 4 into 5 by 5. 3 5s are 15, 4 5s are 20. Again, 12 by 20 multiply by 8, because we want to write 10 rational numbers. Suppose you want to multiply by 10, okay, no problem. You multiply by 10. So which number you multiply easily, take and multiply the number. So 12 8 96. 20 into 8 160, and 15 by 20 into 8 by 8. 8 15s are 120, 20 into 8 160. So 10 rational numbers between 3 by 5 and 3 by 4 are 97 by 160, 98 by 160, 99 by 160, 100 by 160, 101 by 160, 102 by 160, 103 by 160, 104 by 160, 105 by 160, 106 by 160. Okay students, let's do the homework. Exercise 1.2. Represent these numbers on the number line. I already locate the number 7 by 4 on the rational number line. So you need to locate minus 5 by 6 in the number line. So in the denominator is 6. So you want to divide the numbers by 6. That means 0 by 6, 1 by 6, 2 by 6, 3 by 6 and so on. Likewise, number 2, represent minus 2 by 11, minus 5 by 11, minus 9 by 11 on the number line. So you draw the number line, you easily locate 0 after minus 1 by 11, minus 2 by 11, minus 3 by 11. So you can easily frame 3 numbers in the same number line. Sum number 3. Write 5 rational numbers which are smaller than 2. So you want to write 5 rational numbers smaller than 2. What the numbers are smaller than 2? So that is 1, 0, minus 1, minus 2, minus 3 and so on. You can write easily. Fourth sum is not a homework. Sum number 5. Find the 5 rational numbers between 2 by 3 and 4 by 5. Minus 3 by 2 and 5 by 3 and last one is 1 by 4 and 1 by 2. Sixth one, write 5 rational numbers greater than minus 2. So the greater than minus 2 is minus 1, 0, 2, 5, 12, 100, 13. So you want to write only 5 rational numbers greater than minus 2. Okay students, thank you all.